plus yj plus zk. This is vector r such that this r is equal to mod of r vector. That means this r is your magnitude. So the magnitude of the vector is equal to r. It is given. We have to prove that a, b, c, d, this all parts we have to prove. So first is del r is equal to r vector over r, which is equal to r cap. Right? This is your unit vector r cap. We have to note that here you have to remember this, that r cap is equal to r vector over its magnitude. Right? So let's do this first part. So we have to prove that del r is equal to r vector over r, which is equal to r cap, right? Now since we know that r is equal to, vector r is equal to xi plus yj plus zk. So therefore, what is the magnitude for this vector? This is equal to, we know that, x square plus y square plus z square under the root. So r is equal to root of x square plus y square plus z square. Squaring both the sides, we get r square as x square plus y square plus z square. Let's differentiate this partially with respect to x. What we get? 2r del r by del x, which is equal to 2x. So from here 2 and 2 are cancelled. We get del r by del x to be equal to x. R is going to the other side in the denominator of x. So this is del r by del x is equal to x by r. So by symmetry we get del r by del y is equal to y by r. Del r by del z is equal to z by r. Right? So we got the values for del r by del x, del r by del y, del r by del z. Right? These values you need to learn because again and again we are not going to solve this. Just learn these values. Now we start proving the part A. Now del r. What is del r? What is del? It is, yes, I del by del x plus j del by del y plus k del by del z. So this is r. R is, now taking r inside, this is del r by del x plus j del r by del y plus k del r by del z. Now this is, what is del r by del x? We just have calculated, it is x by r. So this is x by r and this is j y by r by symmetry, and this is k z over r, xi plus yj plus zk over denominator is r. So this is equal to, this is nothing but, numerator is nothing but your vector r, yes, over r, and we know that r vector over its magnitude is r cap. So first part is proved. Now the B part, del 1 over r. This I have to prove that this is equal to minus r cap over r square, right? So this is equal to, now I have put the value of del here and it is 1 by r. So let's calculate this. Now if I take 1 by r inside, what is the derivative for 1 by r with respect to x? It is minus 1 by r square del r by del x. Very good. Plus j, this will be minus 1 by r square del r by del y plus k minus 1 by r square del r by del z. Right? This is equal to, now I am taking this minus outside. So this is I 1 by r square. Now what is del r by del x? We know that it is x by r. So I'm writing the value for this, plus this is j 1 by r square. Del r by del y is y by r plus k 1 by r square. Del r by del z is, yes, it is z by r. Very true. So now this is minus, okay, in the denominator I'm getting my r cube, right? So taking this outside, 1 over r cube, and then I'm having, write in other way, xi plus yj plus kz, zk, this is equal to minus 1 over r cube. This is nothing but your r vector, right? And we also know that if we take 1r from this denominator, we get 1 minus 1 by r square, and I'm giving 1r to the denominator of r vector, and this is your r cap, minus 1 by r square into r cap. Hence proved. Alright. Next part. Del r the power n. I need to prove this equal to n r the power n minus 2 r vector, right? Okay, so the value for del is I del by del x plus j del by del y plus k del by del z r the power n. Taking this r the power n inside, del r the power n over del x plus j del r the power n over del y plus k del r n the power del z. Now differentiating this r the power n with respect to x, I will get n r the power n minus 1 into del r over del x. Differentiating r the power n with respect to y, I get n r the power n minus 1 into del r over del y plus k n r the power n minus 1 into del r over del z. Now taking this n r the power n minus 1 outside common, so this will be I have written a cap over it, vector. This is vector I. Okay, so del r by del x is x by r plus j, del r by del y is y by r plus k, del r by del z is, so this is equal to n r the power n minus 1. Yes, in the numerator I am getting my r. This is r vector over r, which is equal to n. Now this r will be taken to the numerator with power minus 1. So this will be r n minus 2 into r vector. Hence the result. Now the last part, D. Del fr is equal to, I have to prove this to be equal to f dash r del r. So now taking this fr inside, del fr over del x plus z del fr over del y plus k del fr over del z. Alright, what is the differentiation for fr with respect to x? This will be f dash r into del r over del x plus j f dash r into del r over del y plus k f dash r into del r over del z. So this is equal to, taking f dash r common, and inside I'm having del r over del x plus j del r over del y plus k del r over del z. Now taking this r outside, del by del x plus j del by del y plus k del by del z, taking this r here. So this is equal to f dash r. This is nothing but your operator del, and this is r. Fine? Okay. So here ends up the exercise. Next time we will be doing some more example on this. By the time, just revise this video. Thank you for watching this video.